This is what uh, error detection and error correction. Okay. And the next, for error detection, we have to use two continuous bits of data. We are using a continuous bits of data, and the main bits of for error detection is one is parity check and second one is cyclic redundancy check. For error detection, for detecting the error, we are using the two main protocols. One is your parity check protocol and second one is your cyclic redundancy check protocol. The error in received frames are detected by means of parity check or cyclic redundancy check. By using these two error detection codes, that is of parity check and the cyclic redundancy check, we are sending the extra bits with the actual data. We are sending the extra bits. Extra bits is nothing but what your data is of 101. Your data is of 101. At the end of the particular bit, we are sending the one extra bit that is called as a parity. One extra bit that is called as a parity. The receiver came to know that is this data is even parity or is this data is of odd parity. The data coming from this is even parity or the data coming from this is odd parity. There are mainly two types of parity checks. One is a even parity, second one is odd parity. Even parity is nothing but what? If the number of ones, if the number of ones is odd, that is called as a odd parity. If the number of ones present in a number of bits is odd, that is called as a odd parity. You have to add at the end of the bit 1. You have to add at the end of the bit 1. If the number of ones is even, if the number of ones is even in the particular bits, you have to add 0 at the end of the particular bit. You have to add 0 at the end of the particular bit. You getting the point? Very, very important. For error detection, we are using the two types of protocols for detecting the error. One is parity check and second one is cyclic redundancy check. If these two protocols, while using these two protocols, you have to send the extra bits with the actual data. We are going to send the extra bits with the actual data to confirm that the bits are received at the other end are same or they are sent. If the counter check at the receiver end fails, the bits are considered as corrupted. Means what? You are sending 101 and the received data is 111. We came to know that whatever the bit we are sending, that is of corrupted one. Next is parity check. How we are going to check this parity check? Once the extra bit is sent along with the original bits to make the number of ones either even or in the even parity or odd in the case of odd parity. I had told you there are mainly two types of parity bits. One is of even parity bit and second one is of odd parity bit. Number of ones is even. Number of ones present in a particular bits are even, that is of even parity. If the number of ones present in a bits are odd, that is called as odd parity. Remember, very, very important. At the time of interview, they'll ask you the question, what is of parity check? What is an parity check? How many types of parity check are present to detect the particular code? One is even parity, the second one is odd parity. The sender, while creating a frame, counts the number of ones. While creating any of the frames, if it is 4-bit or if it is 8-bit, 16-bit, anything. While creating the frames, it is going to count the number of bits, number of ones in it. The number of ones is odd. If the number of ones is odd, we are going to add 1 at the end of the bit. 1 at the end of the bit. If the number of ones present in that bit is even, You have to add 0. See, I have written here is written here, if even parity is used, for example, if even parity is used and number of ones is even, then one bit with 0 value is added. Number of ones is even, then one bit value with 0 is added. This way, the number of ones is remains even. If the number of ones is odd, to make it even, a bit with value 1 is added. Getting the point? So see the example here, 1 0 0 1 0 0 1. You have to count this. How many ones are there here? 1, 2 and 3. How many ones are there? 1, 2 and 3. How many? 3. The number of ones are odd. Number of ones are odd. To make it even, getting the point? Number of ones are odd. To make it even, what you have to add at the end of the bit? 1. See here it is written. If the number of ones is odd, to make it even, a bit with value 1 is added. Even parity. Getting the point? 1 0 0 1 0 0 1 1. So simply we count the number of ones in a frame. You have to simply count number of ones in a frame. If the count of ones is even or even parity is used. Even parity is used. The frame is considered to be not corrupted. The frame is considered to be not corrupted and it is accepted. If the number of ones is odd, odd parity is used, the frame is not corrupted. Still it is not corrupted. So that is what we are going to use the two parity check. One is your odd parity and second one is your even parity. If a single bit flips in transmit, the receiver can detect it by counting the number of ones. You have seen how we are going to count this number of ones. 1 1 1 3. 1 1 1 3. Okay, that becomes even. You are going to add 1 at this. If only two ones are there, 1 and 1, this becomes even. It becomes even. So what we are going to add at this and 0. If even parity is used, 1 1 1 1 1 1, even parity is used, the number of ones is even, then one bit with value 0 is added. 0 you have to add. Just you have to count in a frame how many bits are present. Now many ones are present in that particular frame. If it is odd, you have to add at the end of the bit 1. If it is even, you have to add 0 at the end of the particular bit. That is of functionality of error detection. This is the first step. This is the first method how to detect particular error. Okay.